everyone, this is Sana Batul and today I'm going to represent my paper on the structural equation modeling. Okay, so very first of all, let me give you all an overview of SEM. What exactly SEM is? SEM is a multivariate data analytic technique used to test and establish causal relationship among variables, particularly used in confirmatory modeling. It is a combination of factor analysis and multiple regression analysis, and it used to analyze the structural relationship between observed variables and latent variables. By using SEM, we can be able to test a lot of relationship once rather than one regression at a time. What is the purpose of using SEM? SEM is used to a particular model and to test the strength associated with the model. It also tests whether the model fit over the data as it is proposed, and also tests the group difference and multi-sample analysis on the data. Okay, so very firstly, in order to understand SEM, how does it work? We need to understand the basic concepts of our SEM variable, and they are as follows. The first one is the exogenous variable. These are the synonyms with independent variables. They are thought to be the cause of something. In the particular model of exogenous variable, a particular variable will be going out of that. So basically an arrow will be representing that there is a particular variable that is going out of this model. The endogenous models are the dependent variables, and they are caused by the exogenous variables. In this model, basically the arrow will be coming out of the exogenous. So basically variables are traveling from exogenous variables and to the endogenous variable. Okay, so the next type of variables are the latent variables. They are usually represented by circles, and they are mostly the abstracted phenomena for the model. They are not actually represented by the number in the data set. They are linked to the measured values. The second type of variables that we are going to observe is the manifest variables. Those are represented by the squares, and they are measured from the participants. And then finally is the measurement model. This is the relationship between an exogenous latent variable and measured variables only. They are usually used for describing the CFAs. Okay, so basically what exactly is confirmatory factor analysis? This is used to test whether the measures of a variable are consistent with the researcher's understanding or with the nature of that variable which has been selected. We would be having a bunch of questions and have an idea on how many factors to expect when we are constructing this particular model. So therefore we set up the model with specific questions onto specific factors and then test that the model fits in or no. Also remember that latent variables are the result of the manifest variables. While constructing these models, the general rules that need to be in mind is the latents will be correlated with each other, and the arrows always go from the latent variables to the measured variables, and always leave the error that comes in between the correlation, because that would be the effect that would cause basically on the model. Okay, so the rules we need to follow for constructing a CFA model is that a CAAFI, that is usually the Computer Aversion Altitudes and Familiarity Index. What you have to do is the computer familiarity items would be 3 to 14, 16, 20, 23, 27, 23, because I have taken a particular data into observation, and then the following are the computer altitudes terms and computer aversion items. Usually based on this theory and the manifest variables, we have created one factor model and 3-factor model using the Lavaan package in R. Okay, and based on the various numbers that I have got and the calculations that I have observed, I have constructed the 3-factor model that is from the figure. You can see that it is evident that all the latent variable variants are rounded off to 1, and then the dash that denotes are the scaling in the set to manifest the variables, and the correlations among the variables are moved from moderate to higher ones. Thus, this is the one factor model that I have constructed in the Llavan R package. This is the sample of the variable data that I have been observed while looking at the various 3 models and 1 model of that data sets that have been taken. Okay, so finally in my final report, I would be showing the comparison of fit indices between both these models. Also will be building a path analysis model based on the correlation table that I would be getting. Also a comparison of fit indices of these models. Thank you.